Ever wondered how Netflix knows what to suggest next? In this video, we'll build a powerful recommendation engine using Python. Recommendation engines play a crucial role in today's digital world, driving personalized experiences and powering user engagement across platforms. Today, personalization is key. Recommendation engines are at the heart of this transformation. Personalization is crucial for modern businesses. Users generate vast data daily. Companies use this to create engaging experiences. McKinsey & Company found that personalization can boost revenue by 40%. Consumers expect tailored experiences on platforms like Netflix and Spotify. Businesses must invest in recommendation engines. These tools analyze user data to provide tailored suggestions. This results in longer user retention and increased sales. Recommendation engines boost user engagement. They serve relevant content, increasing time spent on platforms. Amazon's recommendation engine accounts for 35% of sales. It uses collaborative filtering and machine learning. This provides personalized product suggestions. 43% of users go directly to search bars on e-commerce sites. Recommendation engines guide users, reducing confusion. AI in recommendation systems improves effectiveness. AI-powered recommendations can increase click-through rates by 50 to 100%. One Netflix, 80% of content watched comes from recommendations. It analyzes user ratings and viewing history. This keeps subscribers engaged and improves retention. 2. Spotify. It offers playlists like Discover Weekly. It analyzes listening habits to suggest new tracks. Users interacting with playlists are 1.5 times more likely to continue using the app. So YouTube. It uses real-time recommendation systems. 70% of users' time is spent on recommended videos. E-commerce. eBay and Walmart enhance shopping with recommendations. eBay analyzes browsing history and purchase behavior. This increases order values and satisfaction. Of travel industry. Expedia and TripAdvisor offer personalized itineraries. Personalized travel recommendations can boost conversion rates by 60%. Recommendation engines transform user engagement. They meet the demand for personalized content. They drive engagement and satisfaction. Organizations harness data and AI to enhance experiences. This generates greater revenue through tailored interactions. In a competitive market, investing in recommendation engines is essential. The future of customer engagement relies on these systems. Companies embedding recommendation engines will thrive. They improve satisfaction and secure growth in a personalized digital landscape. Our second topic explores the foundational framework of recommendation engines and their inner workings like collaborative filtering. Nowadays, users face an overwhelming amount of information. Recommendation engines help by guiding users to relevant content. Collaborative filtering is a key technique in these systems. It personalizes recommendations based on user interactions and group preferences. There are two main types of collaborative filtering. User-based filtering finds users with similar tastes and recommends items they liked. Item-based filtering suggests items similar to those a user has previously liked. A study found collaborative filtering achieves over 90% accuracy on large data sets. Understanding recommendation engines involves several key elements. Data collection is foundational, gathering user preferences, ratings, and interactions. Explicit data includes direct ratings, while implicit data comes from behavior. User profiling creates detailed profiles to understand preferences. Item similarity evaluates relationships between items using algorithms like cosine similarity. Prediction uses algorithms like matrix factorization to foresee user preferences. A Stanford paper showed matrix factorization improved accuracy by 26%. Despite collaborative filtering's strengths, other techniques offer alternatives. Content-based filtering recommends items based on attributes, like themes or styles. It may struggle with diversity, often suggesting similar items. Hybrid approaches blend techniques, combining collaborative and content-based filtering. Research shows hybrid systems can boost accuracy by over 30%. Recommendation engines have transformed user interactions with digital platforms. Collaborative filtering plays a vital role, offering tailored suggestions. Key aspects like data collection, user profiling, item similarity, and prediction are crucial. While collaborative filtering is powerful, alternative strategies like content-based filtering and hybrid systems provide improvements. Understanding these techniques helps businesses meet user needs and boost engagement. In a rapidly changing digital world, recommendation engines will continue to evolve, shaping user interactions and solidifying their place as critical tools for modern technology. Next, we'll dive into building a recommendation engine with Python. In the digital age, content options are endless. From movies to e-commerce products, choices abound. Recommendation engines help navigate this sea of options. They enhance user experiences by suggesting relevant content. To start building a recommendation engine, set up your Python environment. Install necessary libraries using pip. Ensure Python 3.6 or higher is installed. Libraries like pandas, scikit-learn, and surprise are essential. Pandas is essential for data manipulation and analysis, allowing you to handle datasets with ease. Scikit-learn offers a wide range of machine learning algorithms, making it straightforward to build predictive models. Surprise is a powerful library specifically designed for building and analyzing recommender systems, which simplifies the implementation of complex algorithms. We'll use the MovieLens dataset for our implementation. It's popular among data scientists for its extensive movie ratings. Load it using the Surprise library. Understanding your dataset is crucial. Load it into a pandas data frame to explore its structure. Check for missing values to ensure clean data. Clean data is vital for a successful model. With clean data, create user and item matrices. These are essential for collaborative filtering. The user item matrix is a cornerstone for collaborative filtering. It includes users as rows, items as columns, and their ratings as values. Visualize the matrix to understand its density. Now, implement collaborative filtering algorithms. Use the Surprise library for techniques like singular value decomposition, SVD. Split data into training and testing sets. Train the model to understand user preferences better. Once trained, make predictions for specific user item combinations. This provides insight into user preferences. Predict ratings to see how much a user might enjoy an item. Evaluating performance is crucial. Use metrics like RMSE and MAE to assess accuracy. Precision and recall are important for top-end recommendations. These metrics help understand the relevance of recommended items. Creating a recommendation engine enhances user engagement. Use Python libraries like pandas, scikit-learn, and surprise. Build a system that adapts to user preferences. Continuously assess performance with metrics like RMSE and precision. Improve programming skills and provide valuable insights to users. This leads to a better digital experience. Happy coding! Up next, we'll walk through a hands-on case study, building a movie recommendation system using Python. Movie recommendation systems enhance our viewing experience. Platforms like Netflix and Hulu use these systems. They help viewers discover films they might enjoy. Recommendation systems use algorithms to suggest content. They analyze user preferences and behaviors. Data analysis and machine learning are key. Around 80% of online users depend on recommendations. This highlights their critical role in our online interactions. There are two main types of recommendation systems. Collaborative filtering relies on user behavior and preferences. It recommends items based on similar users' ratings. Content-based filtering suggests products based on prior behaviors. It considers item attributes like genre and director. Our case study will use a hybrid solution. We'll use the MovieLens dataset. It's popular for testing recommendation algorithms. It includes movie ratings, genres, and user IDs. Our version has 100,000 ratings from 1,000 users. It covers 9,000 movies. Before coding, set up the Python environment. Import necessary libraries for data manipulation and analysis. Use pandas, NumPy, and matplotlib for visualization. Scikit-learn and surprise are essential for model building. First, load and understand the dataset. Read CSV files for movies and ratings. Ensure data is clean and structured. Merge datasets to pair ratings with movies. Handle any missing values carefully. Conduct exploratory data analysis before building the model. Identify the most rated movies. Visualize the distribution of user ratings. This provides insights into user interactions with movies. Split data into training and testing datasets. Use training data to build the model. Test data will assess model performance. This step is crucial for accurate recommendations. Build the recommendation model using SVE. This matrix factorization technique reveals hidden features. It helps associate users with movies. Train the model with the prepared dataset. Generate personalized movie recommendations. Use the trained model for any user. For example, find suggestions for user ID 1. Sort recommendations by predicted ratings. Visualize top recommendations to enhance understanding. Display recommended movie titles and predicted ratings. Use bar charts for clear presentation. Every recommendation system has challenges. Cold start problems affect new users or movies. Data sparsity leads to less precise predictions. Future improvements include hybrid models and deep learning. Regular updates will reflect current trends better. This guide outlined creating a movie recommendation engine. From data preparation to model training, each step is vital. Recognizing limitations ensures future enhancements. Start building your own recommendation systems today. The power of recommendation engines in data science. The digital world thrives on data. Recommendation engines transform data into personalized experiences. They guide us to products and content we love. Recommendation systems suggest items based on user interests. They use algorithms to analyze preferences and past behavior. There are 3 main types of recommendation systems. 1. Content-based filtering. It recommends items similar to what the user liked before. 2. Collaborative filtering. It uses preferences of multiple users to suggest items. 3. Hybrid systems. They combine content-based and collaborative filtering. Netflix is a prime example of hybrid systems. Understanding these techniques is crucial for creating recommendation engines. Python is essential for building recommendation engines. Key libraries include Pandas, scikit-learn, NumPy, and Surprise. Pandas helps with data manipulation and cleaning. Scikit-learn provides tools for implementing algorithms. NumPy enhances numerical computation capabilities. Surprise is designed for recommendation systems. Mastering these libraries is crucial for developing effective engines. Experimenting with datasets is vital in data science. Kaggle offers various datasets for practice. MovieLens provides datasets for movie recommendation engines. Spotify's API offers extensive music data. Engaging with these datasets solidifies understanding. Try different filtering techniques and evaluate results. Analyzing techniques in recommendation systems is critical. Evaluation metrics like MA and precision recall gauge accuracy and matentes. Personalizing recommendations boosts user engagement. Research shows personalized content elevates sales by 20%. Continuously refine models based on feedback. Explore advanced techniques like deep learning for improvement. The future of recommendation engines is promising. Advances in data science and AI will expand capabilities. Deep learning can recognize intricate user behavior patterns. Addressing challenges like cold starts is essential. Improving diversity in recommendations is crucial. Real-time data analysis will make systems more adaptive. Experimentation is key to mastering recommendation engines. Start with different datasets and techniques. Consider resources like books and online courses. Join communities for support and guidance. Embark on this exciting journey into data science. The possibilities with Python are vast.